Alright, so in this time problem solving walkthrough, we are going to be using some problem solving techniques to solve a large computation problem. So let's get started. So these type of problems are pretty you'll find them in like math counts competitions. You'll find them in like AMC 8, AMC 10. AMC 12s are mainly focused around like algebra and stuff, but in AMC for math counts, AMC 8 and AMC 10 you'll find computation problems. And in the Harvard MIT mathematics tournament. So let's get started. So we're asked to compute a number here. We're asked to compute a large number cubed divided by this number cubed. Right, and let's find out what number this is. So this is basically the number over here we're dealing with in the like 10,000. So this is 99,990, and actually this is 999,999 cubed over 333,333. So essentially what's going on is we see that this is 3 and 9. And we see that both of them are cubed. Both numbers are cubed. So let's see what happens when we cube 100,000. Even cubing this would be a headache. Right? We don't want to cube. You'd have a lot of zeros. So let's start very small. Let's cube two numbers. Let's start very slow. We're going to cube two numbers. We're going to cube 4 and 2. Now the 4 cube, we can just compute that. 4 times 4 is 16. 16 times 4 is 64. 2 cubed is 8. And we get 8. 8 can be expressed as 2 cubed. So we can say that 4 cubed divided by 2 cubed is 2 cubed. Now I want you to see if you can come up with a pattern to handle this problem. Use this pattern to handle this problem. Now what do you notice here? Well, you can notice that the denominator of this is just the answer. But that's not always the case. Notice something else. 4 divided by 2 is 2. And we have both of these numbers are cubes. They're just cubed. Right? So if we were to do this without figuring out what 4 cubed is, what 2 cubed is, we could have said, hey, 4 divided by 2 is 2, and we had the cubes here, so this is just 2 cubed, which is 8. Now, is this always true? Well, we can always test more examples to see if this is true. So let's test another example. Let's test something like 8 cubed divided by 4 cubed. Now, we already know that 4 cubed is 64. I'm going to write that in the denominator. From the standpoint of our rule, the answer should be the same as this. It should be 2 cubed, since 8 divided by 4 is 2. 2 cubed give us that. So, in 8 cubed, we can just compute that. That's 8 times 8 times 8. 8 times 8 is 64. We need to compute what 64 times 8 is. We can do it by hand. 8 times 4, that's 32. 6 times 8, that's 48. So we have 8 times 4, 32. 6 times 8 is 48. 49, 50, and 51, we get 512. Now we already know that 64 times 8 is 512. That tells us that our answer is going to be 8. And 8 can be expressed as 2 cubed. 8 divided by 4 is 2. We have cubes, we cube the 2, we get our answer, it's working. So now I think you already know that what's going to happen over here. Now all we need to do is divide the numbers, which is pretty easy. I already know it's going to be 3. And we can check that. I have numbers, and I'm going to multiply by 3 since I know this is going to be equal to 3. The division's 3, but not the cube part. And this is 9, 9, 9, 9, 9, and 9. So I already know this is going to be true. But we're cubing both numbers. And now we've known from our pattern that this is going to be 3 cubed. Now computing 3 cubed, we know that 3 times 3 is 9, and 9 times 3 is 27. So our answer is 27. And that's just an example of how you can simplify your problem into smaller parts to come up with a formula type thing or a pattern. So now you know, whenever you have something like n divided by k, n cubed divided by k cubed, or actually, if you have any pattern, n z divided by k to x, or it should be the same thing, so k divided z. You just do n divided by k and just raise it to the zth power, and you're done. That's basically all you do, is you do n divided by k and you raise it to the zth power. That's how you're going to get your answer for any of these. So hopefully this video is helpful, and yeah.